Lesson 17 is about multiplying polynomials, and 17.1 is distributing a constant over a polynomial, which a constant is, it's named after the fact that it doesn't change in value, like it stays a consistent value. So it basically is just a number that is not being like changed by a variable. So like 4 is a constant, or like 10 or negative 12. All those numbers are constants. They're just numbers without a variable. So example 1, multiplying by a positive constant. So in order to do this, we just need to distribute. So we'll take this 6 that's out in front of the parentheses, and we'll distribute it into every term that's inside the parentheses. So to do that, we just have to multiply the 6 by all of the coefficients, which remember that coefficients, those are the numbers in front of the variables, and by the constant at the end. So we'll do 6 times 9x squared. We just do 6 times 9, which is 54. And then the x squared part stays the same. That doesn't change in this case. And then we'll take that 6 and we'll distribute it to the next term, which the coefficient of the next term is actually a negative 5. Remember that if there's like a minus sign in front of the term, it belongs to that term. So 6 times negative 5 is negative 30. And then the x just kind of tags along, same way as like this x squared tagged along here. And then lastly, we'll take that 6 and we'll distribute it to the positive 11 at the end. So we do 6 times 11, which is 66. So altogether, 54x squared minus 30x plus 66. So notice the only thing that changed here when multiplying by a constant was the coefficients. We took 9 times 6 to get 54, negative 5 times 6 to get negative 30, and then the 11, the constant, multiplied by 6 to get 66. Okay, moving on to number 2, multiplying by a negative constant. So still multiplying by a constant number without a variable. This time it's just negative though. So our coefficients will change, but in this case also possibly our sign. So we'll check that out at the end. So we'll take the constant out in front, the negative 3, and distribute it to everything inside the parentheses. So we will do negative 3 times 2ab squared. So we just have to multiply the negative 3 by the 2, and everything else will stay the same. The ab squared will stay the same. So it would be negative 3 times 2 is negative 6. Remember, a negative times a positive is negative, and then the ab squared stays exactly the same. And then negative 3 times just the 5. Negative 3 times 5 is negative 15. And then the a squared b stays the same, so a squared b. And then we take the negative 3 and we multiply it by the negative 7. So negative times a negative turns positive. Remember, if you're like multiplying, if you have two multiplying or dividing, a negative divided by a negative or a negative times a negative turns it positive. So negative 3 times negative 7 would turn into a positive 21. And then the AB stays the same, that just comes down. And then lastly, negative 3 times a positive 1 would turn into a negative 3. So from there, it's always good practice to like check for like terms. In this expression, it kind of seems like we may have some like terms, like we have a lot of A's and B's there, but to be like terms, they have to have the same exact variables to the same power. So like, you know, for example, all 3 of these terms all have A's and B's, but they don't all have the same power. Like this one has an A squared, this one has the first one had an A, the second one has an A squared, the third one has an A. So that second one, the one in the middle, is kind of out. But then if we just look at the first and the third term, A and A, those both have A to the first power, but they have different powers of B. Like one is a B squared and one is a B to the first power, so that would make those different. So none of these terms all have like the same A's and B's to the same exponent. So they're not like terms. So this would actually just be our final answer. Negative 6ab squared minus 15a squared b plus 21ab minus 3. One thing I want you to notice when we distribute a negative constant, throughout the parentheses, all of the original signs change. So what that means is that like positives turn to negatives and negatives turn to positives. So like this was a positive 2, it turned to a negative 6. This was a positive 5, it turned to a negative 15. The negative 7 turned to a positive 21, and then positive 1 turned to a -3. So just keep that in mind. That's kind of a good way to check for any little mistakes, is just making sure that if you're multiplying a negative in, all of the signs change so they switch from positive to negative or negative to positive. Okay, moving on to 17.2. So this is distributing a monomial over a polynomial, which a monomial is usually like a product of, it could be like a regular number, like a constant, and one or more variables. There could be exponents, but it's one term, meaning with a monomial you won't really see like plus signs typically. So example 1, multiplying two monomials. So in multiplication, there is this like property called the commutative property, and it says that if everything is being multiplied together, then we can rearrange what's called the factors, which the factors are like the individual pieces that are being multiplied. So if we look at like every single thing inside these parentheses, like this 7 is being multiplied by the x, which is being multiplied by the y squared. Parentheses are another way of saying multiply, so that's being multiplied by the -2, which is being multiplied by the x cubed, which is being multiplied by the y. So everything in here is being multiplied. So if we want, we can rearrange them to kind of put the things that are similar together. So what I mean by that is, like, I can take my 7 and my -2, and I can write them as their own little multiplication part. So 7 times -2. And then I can take my x's, this is an x, and then this is an x to the third power. I can write them, so x times x to the third power. And then I can take my y's, so y squared and y to the first power, so times y squared times y. So what I did is I took my constants and I grouped those together. I took my x's, I grouped those together, and then I took my y's and I grouped those together. And then sometimes that helps us like organize a little bit better in our heads, so we can go ahead and multiply the things together and combine the correct things to make sure that we're as simplified as possible. So then now if I do 7 times -2, a positive times a negative is a negative, so this becomes -14. And then for my x's, remember when we multiply powers, like things that have exponents and they have the same base, we add the exponents. So in this case, the x's are the base. That first x is just like a first power because I don't see the exponent. And then to combine them, I would have to add the 1 and the 3. So this would become times x to the 4th. And then for our y's, same thing. We have two powers that have the same base that are being multiplied together. This is a y to the first power because I don't see an exponent, and then to combine them, I would add the exponents. So y squared times y to the first power would become y to the third power. Another way of looking at it is if like you don't remember the properties necessarily, you can always take the like x's and y's and what's called expand them. So like let's say I didn't want to worry about the properties. The other approach that we could take for the x's is, so that first x, that's just one of them. And then the x to the third power is 3 more. So times 1, 2, 3 x's. So this is the first one right there, x to the first power. This is x to the third power. And then if I count all of those together, I have x to the fourth power. And then another way of looking at the y's, same concept. So if I take the y's and just go ahead and what's called like expand them, y squared would be y times y. So that's the first y. And then times 1 more y. And then now I have all together 1, 2, 3 y's, y to the third power. So if you don't forget the properties, you can always expand it that way. That just sometimes takes a little bit more time if like the x ones are bigger because you have to write it out a lot. Okay, and then now I have -14 times x to the fourth times y cubed. That is as simplified as we can go, but in our final answer, we usually don't put the little dots for multiplication. If we're just dealing with like one constant and some different variables being multiplied together, I just write them all side by side. So -14, x to the fourth power, y to the third power would be our final answer. Okay, of course, if you get comfortable with these types of problems, you don't necessarily have to do this entire process right here. I'll show you a quick little shortcut of how we got from like our original problem to the final answer. So if I just look at, okay, my constants are 7 and -2. If I multiply those together, I get -14. For my x's, x times x cubed would give me x to the fourth because I would add 1 plus 3 to get 4. And then for the y's, y squared times 1 more y would get me to that y to the third power. So whatever you need to do to get to your correct answer, that's all I really care about. Okay, so negative 14x to the fourth times y, and then we'll move on to example 2. Okay, for example 2, multiplying a monomial by a polynomial 7x times 9x to the second power minus 5x plus 11. We'll kind of treat this just like we did in 17.1, where we need to take that, what's in front of the parentheses, and distribute it into the parentheses. So this time we're going to do the entire 7x, so like all together. So I'm going to kind of write a kind of like a middle step for this example, and then you later on you can decide if you want to include that step in your work in the future or if you want to kind of do that part in your head. So it would be 7x times 9x squared. I'm going to write that all out. I'm not going to like multiply them together yet. So it'll be 7x times 9x squared, and then 7x times, this is a negative 5x, don't forget to include that. So I'm going to do plus 7x times negative 5x, and then 7x times 11, so plus 7x times 11. And then now I'm going to go ahead and multiply these all together. This part that I just wrote is the part that you probably skip eventually once you get comfortable with these problems. So now if I go ahead and multiply the 7x times 9x squared, I'm going to first just multiply the 7 and the 9 because those are the constants. So 7 times 9 is 63. And then if I multiply my x's, remember this is an x to the first power, so this would be like x to the first power times x squared. Same process here. Even if I don't take the time to rearrange it, I still treat it the same way, where I multiply the x's together. To multiply the x's together, I would add the exponents, so this would become x to the third power, because I have one x and then I have two more x's that I'm multiplying in, so altogether I have three x's being multiplied together, which is x to the third power. And then for the middle term, so like this whole section right here, I would multiply the constants. So I would do 7 times negative 5. So 7 times negative 5 is negative 35. So instead of plus, I would write minus 35. And then I would do, trying to keep it as color coded as possible. X times x, I would multiply my x's together, which x times x is x squared. That's just what like x squared means, is two x's being multiplied together. But if you want to think about it in terms of adding the exponents, this would be an x to the first power, this would be an x to the first power. So if I add 1 plus 1, I get my 2. And then for the last term now, I just have my constants that I can multiply together. 7 times 11, which is 77. And then the x, I don't have like anything to multiply it with, so that part stays the same. So it just comes down as just x to the first power. Okay, so altogether, 63x to the third power minus 35x squared plus 77. I am going to run through the original problem one more time just to talk about how we could get directly from here to here as we get more comfortable. So if I distribute 7x times 9x squared, I would do 7 times 9 to get 63, and then x times x squared to get x cubed. And then next, if I'm distributing by the middle term, I would do 7 times negative 5 to get negative 35, and x times x to get x squared. And then to get the last term, 7x times 11, I would just multiply 7 times 11 to get 77. And then the x, I don't have anything to like multiply it by, so it just stays the same. It just kind of tacks on at the end. You never have to skip that middle step like this one right here, but just know that as you get comfortable, you definitely can. So final answer, 63x to the third power, or x cubed, minus 35x squared plus 77x. Okay, moving down to 17.3, distributing a binomial over a polynomial. So a binomial means two terms. So for example, like this first parentheses is a binomial because there's one two terms in there, and then the second parentheses is also a binomial because there's two terms right there. In example 2, this is a binomial, two terms. This one would technically be a trinomial because there's three terms. That's like kind of the end of our like special names after three terms. We just talk about, we call them a polynomial, and a polynomial is just a general term for like any amount of terms. Okay, so for example 1, when we are multiplying a binomial times a binomial, there's like this, I don't know if acronym is the right word, I always forget and get that mixed up, but there's this like kind of trick that we use to help us remember the order that we can multiply in. So the trick that we use is we use the word foil, like tinfoil, but what it stands for is the F stands for first, the O stands for outer, the I stands for inner, and the L stands for last. So F is first, O is outer, like outside, I is inner, like inside, and then L is last. So it's just kind of like an order that helps us make sure that we multiply everything correctly. So example 1, we're going to take 3x minus 1, that binomial, and multiply it by another one, 2x plus 5. So the F first means we take the first two terms in each parentheses, and we multiply those two together. So we take 3x and we multiply it by 2x. So 3x times 2x, I would multiply the 3 and the 2, and that would be 6. And then if I multiply the x and the x together, that is x squared. Okay, so that's the first part. And then I'm going to try to color code as much as possible. I got to erase some of the middle parts just so it doesn't like overlap and turn into like one of those weird brown watercolor colors. So next is outer. So that means we take the terms that are on the outside of the problem. So 3x and 5, those are both on the outside of the problem. So I would take the 3x and multiply it by the 5. That means I would multiply 3 times 5, which is 15. And then I don't have anything to multiply the x by, so that just stays as like regular x. It doesn't change to x squared or anything like that. So this is what we get from our outer. And then next we'll do the inner, which means the terms that are on the inside of the problem. So -1, remember if there's like a minus, it belongs to the number that comes behind it. And then the 2x. So we would do -1 times 2x, -1 times 2 is -2, and then the x stays the same because I'm not multiplying in another one. So that's my inner. And then the last, I would have to multiply -1 by 5 at the end. Oops, forgot to highlight it, sorry. Last means we're taking the last two terms in the parentheses. So the last two terms would be that -1 and that +5, and we're multiplying those two together to get -5 or -5 at the very end. Okay, so that's what FOIL stands for. It's just an order of like how to multiply together. You don't have to remember it, honestly. A kind of a trick that you can also use, I'll go through it just really briefly, is to take, first you take that 3x, and then you multiply it by both of these. That's how we can get these two. So like 3x times 2x, 6x squared, 3x times 5, 15x. And then after that, if I take the -1 and multiply it by both of these in that second parentheses, then I will get the -2x minus 5. Okay, and then after we FOIL, we just always want to check for like terms to see if there's anything we can combine. So like terms are terms that have the same power over the same variable. So our like terms would be the 15x and the 2x. So to get those, I would bring down the 6x squared, and then if I want to combine the 15x and the 2x, when we combine like terms, we just combine / like add / subtract their coefficients, like the numbers in front. So I would do 15 minus 2. 15 minus 2 is 13, and then the x part stays the same. And then I would bring down the -5, and then no more like terms because there's no more like terms that have the same variable and same variable, and same power. So is our final answer. 6x squared minus 13x minus 5. So if this is like, we're going to move on to kind of a longer example after this, but just know there's a zillion videos about like using FOIL and multiplying binomials. You just go to YouTube, go find some. I'll link some on the Canvas homepage. If you just search like multiplying by FOIL, like a bunch will pop up for you and provide you with extra examples if you are interested in them. Okay, so example 2, this is the last one of lesson 17. Multiplying a binomial over a polynomial, and again, polynomial is just like kind of a general term for anything, so we could have like used that for example 1 as a description, but a lot of times when we use polynomial, it just means more than 2, or this is 3, we could use trinomial, but okay, I'm going to stop rambling and just get into the problem. So multiplying a binomial over a polynomial, we don't have like an acronym for this because there's more steps than would be within FOIL, like there's more than just the outer and inner and stuff like that, but the process is the same. Basically what we're going to do is we're going to take this 5a and we're going to distribute it to everything inside that second parentheses. After we do that, we're going to take this negative 2b and also distribute it to everything in the second parentheses. I am going to kind of write a middle step that'll just help us keep our work a little bit more organized as we are like beginning to do these problems. I recommend writing this step as well. Okay, so 5a, we're going to take it and multiply by everything inside there. I'm not going to multiply by everything yet. I'm just going to say 5a times that whole parentheses. So 5a times a squared minus 3ab plus b squared. So 5a times that whole parentheses exactly. And then next I'm going to do the same thing, but with the other term from that first parentheses, so the negative 2b. I'm going to take the negative 2b and multiply it by everything in that second parentheses. I'm just going to write the whole thing out for right now. So negative 2b, remember that the negative belongs to the 2b, so it has to stay next to it, in front of it. And then times the little parentheses, a squared minus 3ab plus b squared. And then now it's just a big distributing problem. So I'm going to move this down so I have a little bit more space to draw the arrows above it. If you don't have a ton of space, it's not a big deal. I just didn't want it to get too messy for you on the video. So now I'm going to take this 5a, multiply it by everything inside there, distribute it to all of them. So 5a times a squared. This is a 5a to the first power, so keep that in mind. This is a like 1a squared because there's no number in front of it. So we would multiply the 5 times the other coefficient 1, which is 5. And then when I multiply the a to the first power times a squared, I would add those exponents and get a to the third power. And then next I take the 5a and I multiply it by negative 3ab. So 5 times negative 3 would be negative 15. And then I can multiply like the a times a, and that would become a squared. But this one, oops, not what I meant to do. This a, this middle term has that b there. There's no other b here to combine it with to multiply by, so it just stays exactly the same. It just tacks on at the end. And then last, from this parentheses, I would take the 5a and multiply it by b squared. Again, this coefficient is 1 because we don't see a number in front of it. So it would just be like multiplying 5 by 1, so 5. And then a to the first power and b to the first power, I don't have a way of combining those other than writing them right next to each other. So it'd just be like 5ab squared. Okay, I want to go through that one more time really quickly. So I took all the coefficients and multiplied those together. So 5 times 1 was 5. And then 5 times negative 3 was negative 15. 5 times 1 was 5. So that's how we got our coefficients. And then for the variables, all of the original terms went up by a power of a because I was multiplying an a to the first power. So all of them should increase by a power of a. A squared became a to the third power. A to the first power of b became a to the second power of b. Notice the b didn't change, just the power of a did. And then b squared became ab squared, just like an a got added in there. Okay, and then we're going to do the same thing now, but with the negative 2b. We just have to be really careful with that negative. So this is a b to the first power, so all of my terms should go up by a power of b, and then my coefficient is 2. So this is a 1a squared, so I would do negative 2 times 1, so negative 2, and then in terms of my variables, I have a b and then I have an a squared. Those don't combine other than writing them side by side. I like to write mine in like alphabetical order though, to keep them like a little bit more organized. So I'm going to put the a squared first and then the b second. It's not wrong to put the b in front of the a squared though. And then next, negative 2b times negative 3ab. So I would take the like negative 2 times the negative 3, that would become a positive 6. And then I'm multiplying in a b to the first power. So this a is going to stay the same. So times a, and then the b times b becomes b squared. And then next, I have to take that negative 2b and multiply it by b squared. So negative 2b times b squared. This coefficient is 1, so it's like negative 2 times 1 is negative 2. And then b times b squared, that would go up to b to the third power, because this exponent was 1 plus 2 is 3. Okay, and really briefly, just to run through that one more time, my coefficient over here was a 2, negative 2, so that means that all of my coefficients inside the parentheses should end up getting multiplied by negative 2. So negative 2 times 1 is negative 2. Negative 2 times negative 3 is positive 6. Negative 2 times 1 is negative 2. And then as far as the variables, I was multiplying in a b to the first power, so all of my terms should go up by 1 power of b. So a squared became a squared with a b in it. ab became ab squared because it went up by a power of b. And then b squared went up to b to the third power, again, because it went up by a power of b, because I multiplied 1 in. Okay, and then now we just want to check for like terms, which these ones are a little bit like not tedious, but like you gotta look really closely to make sure that you don't miss any like terms. So let's see, starting with like the first one, 5a to the third power, don't highlight or underline anything yet. If I look throughout the rest of my problem, there's no other terms that have just a to the third power. So that one doesn't have any like terms, so I'm gonna leave that alone. Let's see, the negative 15a squared b squared, I'm looking for something else that has a squared b squared. I see an a squared b squared, or sorry, I'm saying a squared b squared, a squared b. So I'm looking for something else that has just a squared b. This one has a squared b right there. The numbers in front, like the coefficients, the negative 2, the negative 15, those don't make it like terms or not. We're just looking at the variable part, a squared b. Those are exactly the same, so those are like terms. We'll end up combining those. So let's see. These two will go together. And then right here I have an ab squared. So I would look for another term that has an ab squared, which is that 6ab squared. So they both have ab squared. Those are going to be like terms. We'll combine both of those. Again, the 5 and the 6 don't make it a like term or not. We're just looking at the variables and their powers. And then at the end of the expression, there's this negative 2b to the third power. There's no other term that has that though, so that one doesn't have any like terms. We'll end up just copying it down at the end. Okay, so for our final answer, I'm going to write the 5a to the third power first. And the order here technically doesn't matter. I just kind of try to like copy down as close to the order it was written in originally. And then for the negative 15a squared b and negative 2a squared b, those are like terms, so I get to combine them. I have to add their coefficients. So negative 15 plus negative 2 together is negative 17. And then the a squared b part, that stays exactly the same. That part doesn't change. We just add a negative 15 and negative 2 to get negative 17. And then now for the purples, 5ab squared and 6ab squared, I'm adding the coefficients 5 and 6. So 5 plus 6 is 11. And then the ab squared stays exactly the same. And then the like minus 2b to the third power at the end, that one didn't have any like terms, any buddies, so I just copy that down. So minus 2b to the third power. So final answer, 5a to the third power minus 17b a squared b plus 11ab squared minus 2b to the third power. I'm going to read one more time because I feel like I read it really weird or maybe messed up a term. So 5a to the third power minus 17a squared b plus 11ab squared minus 2b to the third power. Okay, we'll definitely go over more of these in class, but like I said, this is one of those things that's very, very like YouTube video friendly. If you want to look up, really if you look up like any of the like titles of the examples, so like multiplying a binomial by a binomial or a binomial over a polynomial, you will see a lot of videos pop up with extra examples if you're interested.